Here's another example. A truck wheel has a 32-inch diameter. Find the angle through which the wheel turns in 45 seconds if the truck is moving at 15 miles per hour. If the last example felt sort of smooth towards the end, you saw a path through, this would be a good example for you to pause the video and try on your own, and then come back and we'll go through it together. Or you could just keep watching as we go through it together right now. We're picking out what given information there is. The wheel has a 32-inch diameter. Let's get rid of the diameter and go for radius, cut it in half, 16 inches. Next, find the angle. So we're interested in finding theta. We've got a measure of time, 45 seconds. The truck is moving at 15 miles per hour. So here is linear speed. We talked about v being a measure of arc length per time, but remember that example, the first example about a wheel that was rolling forward. We said that a rolling wheel really told us about the arc length. So a truck moving at 15 miles per hour is some arc length per time. So definitely v equals 15 miles per hour. We're going to have several main issues in this one, very similar to the last example. We've got some problems with our units do not agree, and we don't have just one formula to use. We're going to need to use two. If I start out finding the formulas that use theta, because I see I've got to find theta to answer this question, well, my first one, theta equals s over r, got r but don't have s, so hit a roadblock. The other one, theta equals omega t. We've got t but not omega, so same problem. Well, let's go and look at what our other formulas were. We had s equals v times t. We've got v, we've got t, so we could come up with s. And once we had s, I could put that up here and do s over r and get theta. So vt in place of s gives me this new formula, theta equals vt over r. And this looks great because it uses r and t and v, all the quantities I know, and it's going to give me theta. So that's great. And just for a little bit of closure, what happens if we looked at our fourth formula, omega equals v over r? The substitute here, we're putting v over r in place of omega there, and we get theta equals v over r times t. Same formula we get right here. So that's what we'll use. I'm already getting started with my unit conversion now. I've got miles per hour, and here inches and seconds. So the units of distance have to match. Miles and inches are no good. I'm going to go from the big unit miles down to the small unit inches. And I'm also going to change my hour down to seconds. So I'm doing a lot of changes with my linear speed. First, let's cancel the miles and get feet in its place. I don't have it memorized, the number of inches per mile, but this one I know, 5,280 feet per mile. Cancel out those miles. Now, I've got feet. I got to cancel out feet and leave inches, and I can do that with the 12 inches equals 1 foot. Feet units are gone. So a quick survey of what units are left. I'm still looking at inches per hour, and I need to get my hour down to seconds. The hour is in the denominator, so I need to cancel it with hour up in the numerator. And I know 1 hour equals 3,600 seconds. So the hour units are gone. And we're left with inches per second. I need to take this 15, multiply it to each number in the numerators, and divide by each number in the denominators. Actually turned out to be a nice integer, 264 inches per second. So our distances are all in inches, our time all in seconds. We're ready to go to the formula, Vt over r, 264 inches per second times 45 seconds divided by 16 inches. Now our units, the seconds will cancel, and the inches will cancel. Our units have totally canceled, and we know that that means that we have units of radians left over, just in case we didn't remember that theta would always give us units of radians. So this multiply and divide leaves us with 742.5 radians.